Okay, this is 4748. Corresponding parts of congruent triangles are congruent, and isosceles triangles theorems and equilateral triangle theorems. So this is going to be real quick. 47 deals with something called congruent triangles. Wait, no, I'm sorry. Corresponding parts of congruent triangles are congruent. I call it CPCT. Corresponding parts of congruent triangles are congruent. CPCT, sometimes I might put the C at the end, but I don't care. CPCT. And what this means is after you prove two triangles congruent, so let's say this is A, B, C, E, F, G. After we have proven that they're congruent, then we can say any part of them are congruent. So let's say we proved they're congruent because of side angle side. Well, after we've proven them congruent, then any part of these triangles, as long as their corresponding parts, can be proven congruent. So in a proof, we can say that angle B is congruent to angle F, because if we were doing a proof, we would say after we've proven they're congruent, corresponding to congruent triangles are congruent. Or we can say side BC is congruent to side FG for the same reason. So that's what this section deals with. You already have other reasoning for triangles up to this point, except for isosceles and equilateral. So now they want you to prove other stuff congruent by proving the triangles are congruent first, and then using CPCT. Here for number one, they ask you to explain how you can prove that angle A is congruent to angle C. And as you can see, we already have these two triangles with two pairs of congruent sides. AB is congruent to BC, AD is congruent to DC. All we would have to say is that BD is congruent to itself, and then we could say that triangle ABD is congruent to triangle CBD. And then we can say that because of side, 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 then we can say that A is congruent to C because of the CPCT. So if I was to draw this as a proof, and they're not asking for a proof, they just want you to explain it. We start with our givens. Then we can use the reflexive property and say that BD is congruent to itself. Then we can say that they're congruent ABD. CBD. And we can say they're congruent because of side, side, side. And then once I prove that they're congruent, then any corresponding part of these triangles are congruent. So angle A is congruent to angle C. Corresponding parts of congruent triangles are congruent. CPCT. Or CPCTC if you want to write that extra C. Some people do C. Put the C there. CPCTC. It's up to you. Okay. Actually, I'll keep it there because it does make sense. Congruent parts of triangles are congruent. CPCTC. Okay. So that's what this section is basically about. Um, so down here, we have this triangle here, or these quadrilateral broken up into many triangles. So I see 1, 2, 3, 4, 5, 6. I see 6 triangles. They want me to prove that PTU is congruent to U, Q, and P. And I see that I'm going to probably have to prove these two medium-sized triangles. So you have small, medium, and large. Small, medium, and large. I have to prove, let's see, I have to prove the medium triangles congruent by using hypotenuse and leg. I see here that RS is here and PU shares that. So I can say that RS plus PR equals SP. I can say RS plus SU equals RU, and I can say that RU is congruent to PS using the segment addition postulate, and they're adding the same thing. RS is congruent to itself. It's reflexive, so I can say that they're equal. And then I can say that angle TRU is 90 degrees and angle QSP is 90 degrees. Because these are linear pairs and this is 90 degrees, I can subtract it out and say that this is 90 degrees. So this would be a long proof if it was 2 column. So then I can say that triangle TRU is congruent to triangle QSP. And after I say that, then I can say that PT is congruent to QU. Congruent parts of congruent triangles are congruent. Then I have enough information to say that these 2 triangles are congruent, the large triangles, because of side, side, and side. That's a good proof. Makes you think. Alright, if I was to do it for this is going to be a long one. I'll just, I'll have my givens. I'm not going to write it all. And the second thing I'm going to say is that, I'm going to say the measure of angle PRT plus the measure of angle TRU equals 180, and the measure of angle QSU plus the measure of angle QSP equals 180. Linear pair postulate. So we're skipping now the fact that we can say linear pairs because we're kind of more advanced in our proofing. And we can say that linear pair postulate says that 2 angles form 180 degrees and they're supplementary. I can use either or. I'm going to say that angle PRT and angle QSU are right angles. Definition of perpendicular lines. It's going to be a long one, y'all. So then the measure of PRT and the measure of angle QSU equals 90 degrees. Actually, I can't write it that way. Equals 90 degrees. I was trying to save space. Measure of angle QSU equals 90 degrees. Definition of right angles. Then I can substitute it back into 2 and say, this is 90 plus TSU equals 180. And then 90 plus QSP, trying to say space, equals 90, because this is going to be super long. Substitution, then I can say that TSU equals 90 and QSP equals 90. Subtraction. Wow, this is going to be super long. Then I could say that triangle TRU and triangle QSP are right triangles. Definition of right triangles. And the reason I have to say they're right triangles is because so I can use hypotenuse leg. Alright, that's just step 1. So we just established that these two guys are right triangles. I'm going to have to erase this because there's going to be more. So this is a 7-stepper. Do I have enough information? Okay, I think I can do one more. I'm going to make a PS congruent to SU. I'm going to try. And then I can do the rest from there. Alright, so then I can say that P R is equal to SU definition of congruency. Then I can say that RS is equal to itself. Reflexive. Then I can say that PR plus RS is equal to is equal to SU plus RS addition, segment addition postulate. I can also say PR plus RS is equal to PS and SU plus RS is equal to RU. This one isn't segment addition postulate, I'm sorry. This is addition property of equality. This is segment addition postulate. Okay. Alright, so then we've established that. So then we have an information to say that PS is equal to RU, and that's going to be substitution. Alright, I've run out of space. That was 12 steps. So now I'm going to erase this and then move on from there. I actually could save it, but I'll erase it. Next step is line 13. If they're equal, then they're congruent. So then I can say that PS is congruent to RU, and that's because of definition of congruency. Then I have enough to say that the two triangles are congruent. So I can say the triangle TRU is congruent to triangle QSP. And I can say that because of hypotenuse leg. This is 90 degrees, we proved that. This is 90 degrees, we proved that. This guy is congruent to this guy, so that's the leg. And then remember, the hypotenuse is always opposite of the 90 degrees. So I can say that they're congruent. Okay. Now that I can say they're congruent, then I can say that any corresponding part are congruent. So I'm going to say that RT is congruent to QS. CPCTC. Congruent parts of congruent triangles are congruent. So then I can say that triangle, lastly, is 16 steps. Triangle PTU is congruent to triangle UQP. And that's because of side angle side. 16 ridiculous, crazy steps. Okay, not horrible. Okay. And that's that section. So you're going to use various ways to prove triangles congruent. So then we have for 4, 8 isosceles triangles and equilateral triangles. So we have a triangle, and if it's isosceles, that means it has at least 2 pairs of congruent sides, meaning it has these two guys. The side that's not congruent to each other is called the base, and it's produced of base angles. So there's always two base angles. And then the non-congruent angle is called the vertex angle. And then these guys are called the legs. The two congruent sides are called the legs. So this is an isosceles. Isosceles. Isosceles have two congruent sides and two congruent bases or angles, and they're called the bases. The side that connects the two bases that's in between is called the base. The sides that are congruent to each other is called the legs, and then the non-base angle is called the vertex angle. Okay. Theorem 4.7, or base angles theorem, says this: if two sides of a triangle are congruent, then the angles opposite of them are congruent. So, if I know that two sides are congruent, then I know that the two angles are congruent, the base angles. Okay. In the converse of that, if two angles are congruent, then I know the two sides opposite of those guys are congruent. All right. Converse of the base angles theorem, which is the converse. And that comes in handy, actually. Proof of the base angles theorem is right here. This guy here is being drawn. So we draw this JM. We're told that we say that M is the midpoint of KM. So now we have KM is congruent to ML. We have JK is congruent to JL. And then we can say that JM is congruent to each other. So we can say these triangles are congruent from side, side, side. Okay? So then we say that congruent side, 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 then we can say that K is congruent to M. That is our proof. And I'll draw it. So this is actually what we have. We have J. Whoops. We don't have that. We have J, KL. We are drawing an auxiliary line such that it's going to, we're told that this guy and this guy are congruent. We're drawing an auxiliary line such that we create a M, which is the midpoint, and then we're going to say that because M is the midpoint, it's going to make those two guys congruent. So we drew this auxiliary line. 2 points to turn a line, we can draw an auxiliary line. By drawing the auxiliary line such that it cuts this two guys in half, we can say and make this guy congruent to itself. Then all three sides are congruent. Therefore, we can say that anything in it is congruent, meaning that these corresponding parts are congruent. Okay. And that's the proof right there. I'm not going to write it down. Alright, then we have the corollary to the base angle theorem. And it says that if a triangle is equilateral, then it's equiangular. And the corollary to that converse is that if a triangle is equiangular, then it's equilateral, which is very helpful. Since these is an equiangular triangle and this is 5, I know the other two sides are 5. The sum of an equiangular triangle, since they're all the same, is going to be 180 divided by 3, meaning that it's going to be 60 degrees. Okay. We have this diagram right here, and we want to know what x and y are. Since these are equal sides, I know that x is an equiangular and equilateral triangle. It's a regular triangle. And since I know that all the angles have to be the same, I just divide 180 by 3, and I get that x is equal to 60 degrees. I see here that this is 90. I know that this is 60 because all three sides are 60. I'm going to subtract 90 from 60 to get this as 30. Since these are base angles because they're opposite of the congruent side, I'm going to say that this is 30 and this is 30. So together be 60, and 180 minus 60 is 120. So y is 120. Yeah, and that's that section. Hope you have a great rest of your day.